Today, we are joined by outstanding panel of experts. We bring diverse perspectives from academia and industry. It's my honor to introduce our distinguished speakers. First, Dr. Ameena Al-Sumaiti, Head of Smart Operation Lab and Associate Professor of Electrical Engineering at Khalifa University. We have also Khulud Al-Awadi, Director of Advanced Technology Services at Moro Hub. We also have Adithya. He's a Director of Energy Industry at Presight AI. My name is Ahmed Al-Afari, and I am a researcher in the Advanced Science and Artificial Intelligence at the ECSSR. And it is truly a privilege to serve as today's moderator. I encourage all participants to stay engaged throughout the discussion and just keep your questions at the end once we are opening the floor for the Q&A session. So without further ado, and with our distinguished speakers and audience, let us begin. Dr. Ameena, how will the growing of integration of artificial intelligence reshaping the global energy demand patterns, and which layers of the AI ecosystem are likely to exert the strongest influence?
Now, the artificial intelligence will shape the energy demand globally in terms of the quantity and the structure. The AI applications will demand a huge energy demand, which is expected to grow in the future. And this is driven by the demand for data centers. The data centers are actually energy intensive. And this energy demand requirement will increase in size when it comes to the further deployment of generative AI and large language models. Now, to imagine how much energy is needed, you can imagine the amount of energy needed to power hundreds of households annually. And that can resemble the amount of energy needed by the data centers themselves. Now, according to the International Energy Agency, the amount of energy needed by the data centers is expected to grow and double by 2030, and that would account for almost 3% of the global energy demand. Now, the data centers are composed of servers, cooling and predictive control systems, and then they also include the storage systems and the networking equipment. The servers themselves would mandate 60% of the energy demand. When it comes to the cooling and control systems, they will mandate 30% of the energy demand. Now, there is the 5% energy demand, which can be dedicated for the storage system, and another 5% of the energy demand, which will go to the networking equipment. But is that the whole story? Definitely not. Now, there is another aspect of the energy demand associated with these data centers, and this is driven by the locations where these data centers are installed. And here it comes the energy demand for lights and uninterrupted power supply. And again, that will overall contribute to the overall energy demand. Now, when we think of the AI ecosystem itself, we need to think of multiple layers. The first layer is the data itself. The amount of data we need to be utilizing to process the AI models would definitely be a contributing factor to the energy demand, because these data should be stored in somewhere. And the storage itself is going to contribute to the energy demand. Now, the other layer is the model layer, is where basically you're considering your algorithm. And each algorithm itself will have a different contribution to the energy demand. And this is driven by the complexity of the algorithm and the computational speed of the algorithm. There is also another layer, which is the software layer. And then you need to define which platform you're going to be using or which software you need to use in order to run your AI model. Another contributing factor or a layer is the hardware layer, and that includes the CPUs and the GPUs, which are actually energy intensive. Now, there is also what we call it, the people and the organization layer. And you might wonder where the people and organizations comes here into the cycle. Well, if you consider, for example, the utilization of a chatbot, the amount of energy needed by the chatbot is defined by the workload. And that workload is driven by the number of users utilizing it, the amount of information that they're feeding it to the chatbot, and the size of the workload itself. So the volume is also a contributing factor. But since we have been talking about the energy demand requirement for the data center, and we've been talking about the AI ecosystem, now the question is, how can we solve such a challenge? Now, we can benefit of a previous trend applied in the power system, and that is the demand response concept. Now, you capitalize on the concept of the demand response in order to schedule the energy needed and taxed for the data centers. And especially during the times where we have peak generation from renewable energy generation systems. In this case, we're not going to be only solving the challenge of energy demand needed by the data centers, but we will also be able to solve a critical challenge for the power system, which is the curtailment of renewable energy systems. And why do we expect to have curtailment? Now, with the plan towards increasing the capacity of renewable energy integration and their penetration to our today's grid, the grid is not going to be capable to withstand all such a penetration, especially when the target is to become clean. Now, one of the options is to capitalize on investing in energy storage systems, and by themselves, they are really high in capital cost. So an alternative that could contribute to solving the challenge of avoiding the curtailment of renewables is to direct that amount of energy generation to the data centers and then schedule the tasks. Now, there are a few things also that we need to think of that can frame future research directions. One of them is that, can the AI optimize the energy consumption needed by the data centers, while it is still a contributing factor to the energy demand? The other question is, to what extent these data centers are secure and resilient to cyber physical attacks? And what's the impact of the failure of the data centers on the investments, on the applications of artificial intelligence from the economic aspect? And if there is a failure tomorrow and all the investments are going towards, let's say, for example, if somebody decided to invest in AI, what's the impact? So a risk assessment and an alternative solutions should be thought of early ahead. The last question, and it's a very interesting question, is where should we allocate these data centers? Because one of the contributing factors to the energy demand is the heating, and we need the cooling. So at what size and at what locations we should allocate these data centers?
You just mentioned some mind-blowing piece of info. You said energy will double by 2030 for us to operating the AI system. This will lead me to the next question to Khulud Al-Awadi. How can AI model architecture, training practices, and hardware choices be redesigned to minimizing energy per useful outcome?
Yes, thank you, Doctor. Just to echo what you have been saying, energy efficiency is not a byproduct of innovation anymore, and it needs to be engineered into every layer of the AI stack. Starting from model architectures, instead of training massive general purpose models for every task, the trend is moving towards smaller and more task optimized kind of models, which consumes a fraction of the power but still delivers precise and high performance results. And another area also that I would like to discuss is the training practice. So fine-tuning, we are able to significantly reduce the cost and energy footprint for the training itself, meaning we are using the existing intelligence instead of rebuilding it from scratch every single time. And talking about the physical layer, the smart chips that we are seeing, they're arising right now. We are seeing smarter chips that are handling energy much more intelligently. And an example of that would be something called the dynamic voltage and frequency scaling, if you've heard about it, which allows the processors to automatically slow down or speed up to handle the workload, which helps a lot in saving energy as well. And of course, finally, I'd like to say building AI data centers that are fully running on renewable energy helps reduce a lot of carbon emissions. And I think today, from my standpoint here, representing Moro Hub, we have built the world's largest green data center, and it is an AI data center that is fully powered over solar energy, located in Mohammed bin Rashid Solar Park in Dubai. So all these innovations, I think, they mark a major shift towards achieving a energy efficient performance.
Thank you so much, Khulud, for your thoughtful remarks and ideas. I want to ask Adithya, since he's from Presight, a G42 company, how is Presight turning the AI and energy paradox into an opportunity for national efficiency and resilience?
Thank you, Ahmed. And before I answer this question, it's my gratitude to the Emirates Center for Strategic Studies and Research for hosting all of us today and conducting this session.
You're very welcome.
Thank you to the wonderful audience who are here. It's a full house after lunch. Fantastic. Thank you, Dr. Ameena, and thank you, Khulood, for some great answers so far and making it difficult to say anything that you haven't already said so far. So I represent Presight, which is one of the G42 companies. And G42 has the entire value chain of technology transformation, starting from sovereign data centers all the way until sovereign applied artificial intelligence. So I think the key to this answer is actually to step back. For centuries now, in every language, in every country across the world, there's a quote that all of us have grown up hearing, that knowledge is power, right? This is something we've heard thousands of times during our own lifetimes. Obviously, this started with the concept of libraries, which is where we're seated inside today, right? So I went to Harvard Business School, which one of the reasons why it became so successful was it had one of the largest libraries in the world. So for the longest time, the one with the largest library was most successful. The internet changed this. It put a lot of it online. Today, that's changing once again. And we're now reaching a point where to power a lot of artificial intelligence, you need electricity. So we like to call electricity as energy or as power. So I think that statement has changed. It's no longer knowledge is power. It's now power is knowledge. That statement has changed everything for us today. So the organization with the most power, or the country with the most power, can ultimately generate the most intelligence that can then lead to efficiency and knowledge back again. So at G42, we've obviously announced Stargate, which is a 5 gigawatt data center, along with the United States. Microsoft is one of our largest investors at about $1.5 billion into G42 and $15 billion into the UAE to launch Stargate and many other ventures. We've got Khazna for data centers, Core 42 for sovereign cloud, there's Presight for applied intelligence. Inception launched an Arabic LLM, so all the AI that we use today is in English, like ChatGPT and Copilot and so on. There's Jace from the G42 group that's in Arabic. So it's diversifying beyond English language as well. And all of this ultimately feeds back into energy efficiency, given most of the work that we're doing here, whether it's with the Department of Energy, or with ADNOC, or with Masdar, or with TAQA, or with EBEC, all of these organizations are dramatically improving their efficiency by using artificial intelligence. So as much as there's power being consumed to run AI, this AI is able to help you reduce power consumption at the end. So we're ultimately hitting a net zero, which was committed during the COP28 in 2050. So the way we're moving forward, I see more of zero carbon funding into emissions, and then that runs AI models, and that ultimately drives more efficiency, leading to a better world with lesser energy consumption. Thank you.
Thank you so much, Adithya. You mentioned energy efficiency, which is really something that has to go hand to hand once we are developing AI. This will take me to the next question to Dr. Ameena. Which operational applications of AI deliver the largest immediate energy savings across generations? Grid operations, storage, and end-use sectors.
Thank you, Ahmed. In fact, there is no single answer to such a question on the cost savings when it comes to the sector, whether it's the generation, whether it's the operation, or it's the storage, or the end users. Because the cost savings would be driven by many factors. One of them is the geographical location. The other one is the size of the infrastructure where the artificial intelligence is applied. And the third one is the type of operation okay? And this is why I'm saying I cannot give you an exact answer to your question. But nevertheless, according to the literature and many of the studies has demonstrated that one of the really priority sectors is the building sector, where the building sector accounts for 40% of the energy demand globally, along with the industrial processes. When we think of the application of AI in the building sector, why it serves as a quick win solution, because the energy demand in that sector can be driven, well, by the customer demands at the end of the day. And with the integration of AI, you can integrate the AI with the optimization models and try to come up with a smart predictive control for whatever activities that run of the house. And the companies has been reporting savings that can reach between 10 to 25% within a few weeks from the installation of the smart appliances, the integration of AI for the smart control of the HVAC and the lighting systems. So these could be certain aspects, but we shouldn't be forgetting an important fact that the AI applications could have a further deployment across the generation, storage, the transmission system, and the end users. Now, when it comes to the generation side, the AI will help to forecast the renewable energy systems, such as the PV and wind systems, because they are uncertain in nature, and accordingly schedule the generation side, because we could have also fuel-based generations. And we need to understand how much renewables is available, such that we can minimize on the amount of energy needed from the fuel-based stations. Also, we can use the artificial intelligence at the generation side in order to monitor the equipment status. Through measuring the vibration and utilizing sensor data, we can tell if the equipment is undergoing a failure, as in the case of the gas turbines or the wind farms. At the transmission side, we can look at the frequency and voltage measurements and utilize the AI in order to predict if there is a fault is going to take place in the system or there is a future stability issue. And by then, we can minimize the opportunity for faults and consequently avoiding in the future power system a blackout, which is going to be a major challenge. Now, when it comes to the end users, we can forecast the energy demand, whether it's at aggregated nodes of the grids or it's at the individual houses or at specific processes. But at the same time, we can also monitor the health of the transformers, because we want to avoid at the end of the day any transformer burnout. Also, we can utilize artificial intelligence in order to predict electricity theft, because some people could go and steal the electricity, and this is really challenging in many of the developing countries, why they cannot accommodate the growing energy demand, because many people are not following the regulations and are stealing the electricity. Now, when it comes to the storage system, we can utilize the artificial intelligence to do many things. One of them is to anticipate the degradation in the life cycle of the energy storage system itself, and then utilize such an information and also help in scheduling the charging and discharging sessions for the storage system such that we maximize its lifespan. Now, also, there is another aspect or another factor that contributes to the energy demand and where artificial intelligence is going to be very helpful. Now, with electric vehicle penetration in today's mobility networks, they're accounting for part of the energy demand. And now with the utilization of the artificial intelligence, we can predict the traffic congestions. And then we can define the optimal routes to minimize the amount of energy that is needed. And this is an indirect application where AI comes into the cycle. But nevertheless, AI was going to play a huge role when we talk about decoupling of networks. For example, when we come up to the concept of the water energy nexus, which has been now trending, now artificial intelligence is going to support the prediction of the renewables, which can come and form the concept of the virtual storage along with the operation of the water energy nexus, such that we can improve the overall energy efficiency by having that interaction between the water network and the energy network. But at the end of the day, we shouldn't forget an important fact, that the data centers at the end of the day is going to really contribute to the amount of energy needed. And then also the algorithms themselves are key players.
Thank you so much, Dr. Ameena. I totally agree with you. I think AI, at the end of the day, it's an enabling technology. It can be harnessed to find the new opportunities as well as to get rid of the challenges that we have today. My next question might seem a little geopolitical, but just make it. My next question is to Khulud Al-Awadi. OpenAI recently warned in an open letter to the White House that the United States may lose the AI race to China because of energy. To what extent do you agree with this aforementioned?
Well, it is a geopolitical question.
Sorry for
And
that.
I'm happy to answer it. No, I enjoy geopolitical questions actually. So if we talk about the global AI race, the United States and China are representing two very different strengths here. The United States, they are leading with innovation. They have top AI labs, model developers, they have a strong AI ecosystem. But as you've mentioned, OpenAI, they highlighted in their letter to the White House, the real bottleneck is in energy because the US might be limited with the grid capacity, slow regulatory permits, and so on. On the other hand, China, they are building data centers and energy capacity in record speed. However, also China's system is constrained with limited access to chipsets and weaker global trust, I would say. So both are strong, but both are incomplete. This creates a bit of a strategic balance. Now, do I think the US will lose to China because of energy? Not entirely, because in my point of view, the AI race is a strategy race. And the US are leveraging their global partnerships to bridge their energy gap. And a significant example I could share today with everyone here is the growing collaboration with the UAE. The US and UAE partnerships in this space of AI and energy. I mean, the US issue is they are trying to scale a reliable, high performance or high capacity energy infrastructure to cater for their AI exponential growth, whereas the UAE have already invested and built a foundation and a backbone for a future world-class energy infrastructure. So I think the AI race will not be identified honestly by which nation or nation's victory over another nation, but rather will be identified in coming future by collaboration. Because progress, I'm telling you, it will be measured by the collective global advancement.
I totally agree with you, Khulud. I think at the end of the day, we always ended up with collaboration. We think we will build big mountains, but at the end of the day, we just have to collaborate in order to move in this global race. So let's move from geopolitical landscape to a technical landscape, which Adithya, he loves. My question to Adithya, what are the technical advantages of a unified platform for energy and water? And how does this position Abu Dhabi for a rising AI demand?
That's a wonderful question, Ahmed. Thank you. So as much as your question is limited to electricity and water from what you mentioned, I think it's fair to say that energy is a combination of your fossil fuels or your gas, petroleum, and then you've also got renewable energy, whether it's nuclear, solar, wind, and so on. So I want to talk about both, and the unified advantage is what makes energy production a lot more strategic and a lot more sustainable. So I want to talk about two different projects that we worked on at G42, Presight and AIQ specifically, that shine more light on both these aspects. So I want to start with a project that we worked for ADNOC. So under, of course, the guidance of the visionary leader, His Excellency Dr. Sultan, the group CEO of ADNOC, we worked on a project called Energy AI. So the idea was to use agentic AI in your upstream oil and gas operations, something that had never been done before. And as all of you know, ADNOC is one of the most strategic organizations in the world, not just the UAE, right? The fact that all of us are sitting in this comfortable, air-conditioned, incredible landscape is because of ADNOC in many ways. We would be in the desert otherwise, right? So ADNOC has played a very significant role, and when this started, the initial mandate was to build a proof of concept, but we said we'll go a step ahead. We'll build an IOC, an independent operating capability. So it's not just proving something, but it's something that's full and then can be scaled to a larger concept. So it started with one use case, which is enhancing seismic interpretation accuracy of the oil wells in itself. Within 90 days, we brought in a 70% improvement in this accuracy using agentic AI. This led to the Energy AI project being awarded for $340 million to the G42 group along with Presight and ADNOC. This was going to go across all the oil wells, about 28,000 of them across the UAE. And with this, we're trying to drive, finally, one point. That's as much as we have AI for energy, this will also help you with energy for AI. So that was the point of all of this. With this, you'll again drive efficiency, make it cleaner, zero carbon, net zero. So it's not just AI for energy, but it's also energy for AI.
I like that, Adithya. I think you want to say, like, we have to be smart to deal with smart.
Absolutely.
So that definitely correct. I think it's time for us now. Do you have anything to add?
I was going to talk about another project, but
Yeah,
we'll
sure.
answer
Go
it.
ahead.
Don't worry.
No. You know, go ahead.
So
Continue.
the other project I want to talk about was what we worked on for the Department of Energy. So that was under, again, the vision of His Excellency Dr. Abdullah. His vision was, today you've got multiple productions of energy. You've got nuclear, you've got solar, you've got wind, you've got oil, of course. There isn't really one place where we're able to visualize and understand what's being produced where, and what's being consumed where. Is it going to an industrial use case? Is it going to academia? Is it going to a house? And so on and so forth. So what we built was this single source of truth. It's an integration of all energy production, all energy consumption at one place, so you're able to drive a more efficient energy mix. So with this product today, we've increased electricity efficiency by 30% and water by 20%. So that's, again, driving sustainability for the Emirate of Abu Dhabi and so on. Thank you, Ahmed.
Thank you so much, Adithya.